Hello everyone. So today's topic is going to be simple interest and compound interest. So let's try and understand the concepts and the questions that are related to that. So let's first begin with the idea that what exactly is interest. So let's say whenever we talk about interest, obviously two things that should normally come to our minds. That is, one is let's say when you take a loan or something. So while paying back that amount, you have to pay back some extra amount also in terms of interest to use that value, to use that amount for certain time being, and that is one aspect. The second aspect of interest can be, let's say you have invested some money and after certain duration you get certain extra returns also. That can be also called as your interest. So that is with the interest part. Now, what are the concepts that are related to interest? Let's try and understand that in detail. So let's first talk about simple interest, and then we'll gradually go to the other ideas basically. So talking about simple interest first. So simple interest, as the name only suggests, it is very, very simple in the sense that one very simple parameter that we can remember simply, that is, it is going to be fixed every year. So whatever is, let's say, promised to you at the beginning of the duration, you'll keep getting that same number no matter what scenario. So let's say you make an investment in an FD. So obviously they will already tell you that you are going to get 6% or 7% as returns. So no matter what happens for the next 1 year or whatever the duration is, you are going to get that fixed returns basically. So key part is fixed return, and it is constant every year. So that is simple interest. One very famous example, we can say R% of P basically. So R is our rate of interest and P becomes our principal. Now there is one formula for simple interest that we'll have to remember, and that is going to be probably you can also guessed it correctly, which we have done in the school time. It is PNR upon 100, where P is your principal, N is your number of years, and R is your rate of investment or rate of return basically. Some people use PRT upon 100, and that is absolutely okay also. There is no difference there. The nomenclature is slightly different. Then comes on very basic formula that you will also have to remember, that is going to be for amount. So this amount is basically principal plus interest. That is the formula for amount that we'll have to also remember. Now to proceed further, there is one more property that we need to understand for interest. But what we will do is we'll take a quick example of certain numbers. So let's say what do we have? So let's say we have 1,000 rupees principal, and it is getting invested at 10% per annum return. And let's say if it is going to be simple interest, then what really happens here? So obviously, as the name suggests, it is fixed. So every year you are going to get 10% irrespective. So 1,000 ka 10% becomes 100 rupees. So in the first year you get 100 rupees as the returns. In the second year you are also going to get the same number, that is going to be 100, and so on and so forth. So for all the 5 years you are going to get the same number, that is going to be 100 rupees each particular year. So let's say at the end of 5 years, if you withdraw this, so you are going to get 1,500 as the total amount, which is going to be 500 rupees your total interest, and 1,000 rupees was your principal, if you remember. Now let's say someone wants to withdraw after 4 years. So how much he will be getting? So obviously 1,400 he will be getting. Somebody who does it after 3 years, they will be getting 1,300, and so on and so forth. If you now understand the property, and this is what I was going to tell you, that when it comes to simple interest, the difference between consecutive amount is always same. So for example, 5th year ka amount is 1,500, 4th year ka 1,400. If you take the difference is going to be 100 rupees. Similarly, 4th year and 3rd year, the difference is again going to be 100 rupees only. So that is the property that you need to remember. So as you can see, it is mentioned here, which is slightly written in a different way, which says that the difference is same. But which difference? Always remember, it is going to be the consecutive amount का difference. So these are the things that we need to remember or understand when it comes to simple interest. Moving forward, let's talk about compound interest now. So compound interest, as the name suggests, it is not going to be fixed. It is going to keep on increasing every year. And why it keeps on increasing every year? Because the principal keeps on increasing every year. And why principal increases every year? Because the previous year's interest is added to the principal. So for the next year the principal becomes bigger, and on that bigger principal you get a bigger interest. So that is with the compound interest. So we can simply say the formula in compound interest, you directly get the amount basically, and that amount is given by a formula P into 1 plus R by 100 the whole raised to N, where P is your principal, A is your amount, the final amount that you get, R is your rate of interest, and N here a lot of people mistakenly say that it is number of years, but it is not number of years. You have to be very particular about it. It is number of time periods of compounding. Now why so? So for example, let me give you a very quick idea so that you can understand this clearly. So let's say your duration is 1 year, and let's say you are going to do annual compounding. So this means that in every 1 year the compounding is going to happen only once basically, because it is annual compounding. But let's say if the duration is 1 year, but let's say the compounding is going to happen 6 month period or half yearly basis. So this means that in 1 year the compounding is going to happen 2 times. So in this case, if you take the value of N as 1 considering the number of years, then you are going to make a mistake in the calculation. So that is the reason, always remember that in compound interest N is not the number of years, it is going to be number of time periods of compounding. That is how many times compounding happens. You need to understand that. Similar example, there is one more property that we need to do, but to understand that property, let's do that example. So same data, 1000 rupees is our principal, 10% is the rate of interest. Let's say if you do it for 1 year, you are going to get 10% on that, which is going to be again 100 rupees for the first year. But in the second year, what really happens, the compounding kicks in. So for example, the first year's interest of 100 rupees should be added to the principal of the second year. So for the second year, your principal is not going to be 1000, it is going to be 1000 plus 100, which is going to be 1100. On that 1100 rupees, you are going to get now 10%, which is going to be 110 rupees you are going to get the interest. Same thing should continue for the next year. This 110 should be added to 1100, makes it 1210 as the principal, new principal for the third year, and on that you are going to get 10%, so that is going to be 121 rupees again. Similarly, again that will be added, so your principal becomes 1331. On that you get 10%, so going to be 133.1, and so on so forth. So after 5 years, let's say someone asks you that how much amount you are going to be generating, so you'll have to add all the 5 interests and also the principal of 1000 rupees, so that makes it 1610.51 as your number. And as you can clearly see, the interest keeps on increasing and increasing and increasing, unlike simple interest where the interest was constant, where it was fixed. So this is really the idea of compound interest that you need to understand here. Now, what is the property that you need to remember for compound interest? So for compound interest, the property is very simple, that the ratio between 2 consecutive years is same or is constant. So for example, let's say the amount at the end of the 5th year, let's call it as A5 for example, to keep things simpler, and let's say the amount at the end of 4th year, which is A4. Now whatever is this ratio is also going to be same for amount of 4th year and amount of 3 years ka ratio. So hence the property is that the ratio of 2 consecutive amount is equal. So that is the idea that you will also see where they say that the ratio is same, but you have to understand which ratio is same. So any no random ratio is same, it is going to be the consecutive amounts ka ratio that is going to be same. So these are the things that are related to compound interest in terms of basic philosophy that you need to to remember basically. So now moving on to the next idea, which is alternate ways of looking at compound interest, and this becomes interesting because what really happens is the formula of compound interest that we have given you in the previous slide, which is this one, amount is equal to P into 1 plus R by 100 the whole raised to n. That formula we will try not to use many times, and that is the reason why we need to look at the alternate ways also, because sometimes the calculations can be very overwhelming when the numbers are not friendly. So let's have a look at what are these all things that we need to understand. So first part is going to be that we can use fractions. Again, if you have attended or understood percentages class, why you will realize that this idea of percentages and fractions is so very crucial for the same reasons. So here, if you remember that the rate of interest was 10%, which was not very bad number, but let's say the number is bad, like 12.5% or something like that, or 16.6%. Instead of those numbers, we are going to use the fractions, and compound interest is obviously percentage increase, and for percentage increase we have given you one formula, which is 1 plus base fraction. This is what you need to remember. So obviously considering the same number, that is 10%, so 10% ka fraction becomes 1 by 10. So for us this number becomes 1 plus 1 by 10, which eventually becomes 11 by 10. So what is this idea means really is that if you, let's say, take one number and if you multiply that one number by 11 by 10, you are going to get the next number. Again, if you repeat the process, if you multiply that number by 11 by 10, you are going to get the next number, and so on so forth. And obviously when we do that for principal also, the same philosophy holds true. So very particular idea. Percentages we can use, and because it is percentage increase, so the formula is 1 plus base fraction, and you should be very good with the percentage and fractions calculations. So 1 plus 1 by 10, 11 by 10. That is your multiplying factor basically in this particular example. So that is one way that we can use fractions basically. The other thought process that we can think of is a very fundamental idea of compound interest, which is interest on interest. So what really happens in compound interest, that is, not only we take interest on the principal like simple interest, but we also take interest on the interest as well. So for example, let's say you are having a principal of 1000 rupees, you are gonna do 10% on that, which is 100, but on that 100 rupees also you are gonna go do 10% of that. So 100 ka 10% becomes 10, and that is why for the second year you get that additional kicker of 10 rupees of the return. So basically that 110 ka breakup becomes what? Whatever is the previous year ka interest, which is 100, and on top of that also you calculate R% of that. So 100 plus 10% of 100, which is 110. Same can be done for 121 also. So for example, 110 was the previous year's interest, and you also calculate 10% on that. So 10% of 110 is going to be 11. So 110 plus 11 becomes obviously 121 as your number. So this is another idea that you can also use or think of, which is interest on interest. So that is one more process for compound interest basically. Now going towards the next method, which is again interesting because this is exactly what we did in couple of classes before, that is the idea of successive percentage. So why we can do that? Because obviously we have more than 2%. Here we have 5 percentage numbers. So again, this example can be not a right advocate, but try and understand the underlying idea behind it, that you can use it also. So for example, here we have 5 numbers. We can start with any 2. So all these are positive because they are returns generated unless and until mentioned negative otherwise. So let's use the formula, which is a plus b plus ab upon 100. So for the tens, if you the first 2 tens, if you do the successive, you get the answer to be 21%, because 10 plus 10 is 20 and 100 upon 100 is 1. So 21 is the net change for the first 2 years. Similarly, you can continue doing that So 21 plus 10, again if you do the successive, again if you substitute, calculate, you'll get 33.1%. Again if you do that one more time, you're going to get the final answer basically, which is 46.41%. And for the last number also one more time for the fifth year also. So if you keep continuing that, you get a final number which gives you the total interest. So folks, remember all these three alternate scenarios also, and then obviously you have the formula also. So basically you have four different approaches to calculate compound interest. Depending on the data, depending on the comfort of the numbers, you can choose any one of the few. That is absolutely okay basically. So that is with the idea of alternate ways of looking at compound interest. Moving on further, the next part is even more important, which is slightly different. So I will take it up here, which is difference between SI and CI. This multiplicity of principal will do it in a while. So just hold on for this bit. There's another idea which is going to be difference between simple interest and compound interest. Now why we need to know this? Because there are bunch of few questions that are there normally on this idea also. So we need to do this. Now for this, what you can remember is you can have a look at that table that we have done previously. So you'll have the handouts in front of you. You can refer to that very easily and you'll understand what I'm saying. So if you remember, for the first year, if I ask you, for the first year, what is the difference between SI and CI? And if you go through that table, you will understand that for the first year the simple interest was also 100 and the compound interest was also 100. So that means for first year there is no difference between SI and CI because they both are really the same. So there is no difference for the first year. They both are equal. They both are same. So that means the difference actually start coming from second year onwards basically. Why so? Because simple interest jo hai apna, that is going to remain 100 only because it is fixed every year. But compound interest, what happens to that is it keeps on increasing and increasing and increasing further. And you will see that for the second year the compound interest for the same numbers are 10, 110, then 121 and then 133.1 and so on and so forth. So the difference will start coming in. So if I ask you for the second year how much is the difference between SI and CI, so you will say that the difference is going to be 10 rupees basically. Now let's try and understand why this 10 rupees as the difference comes, or rather from where it comes in the first place. So if you remember the underlying philosophy of compound interest, which is not only we calculate the interest on the principal, but we also calculate it on the interest also. So what we can understand is this 10 rupees ka difference for the second year can be represented in the formula as R% of I1, and I1 is first year ka interest. If you remember first year ka interest, it was 100 and 100 ka 10% agar hum kare, so obviously we are going to get the 10 rupees difference, and that is why the formula is like that, R% of I1. Just simply remember that I1 is the first year ka interest. Now another formula is also there which you can remember, and it is again going to be the same extension of the idea. So this I1, the first year ka interest, if you think about it, how do you arrive at that first year ka interest? So again, very simply, if you remember, how did you arrive at I1? So you did what? You did 10% of 1000 if you remember. And so that I1 basically can be replaced as R% of P. The I1 can be replaced as R% of P basically. So basically you have two different formulae for a difference. One is your R% of I1, which is basically this idea, or rather this formula, and the second one is this one, the bottom one that we have written, which is going to be R% of P basically. So that is your second particular formula that you need to remember, folks. So these are the two formulae. Now depending on the data, whichever is convenient to you, you can use one of the two formulae, and that is absolutely okay. So remember this. We are going to do questions on this, and obviously you will remember all of these things when we do them. So that is about difference between SI and CI. So just make a note of all of this. Pause this video, take a snap or something if you want, so that you can copy paste it later, or just write it down in your notes. So this is about the difference between SI and CI as a small concepts which is related to questions. Now let's look at the other idea, which is going to be multiplicity of principal by integral number of values. Now this is a very straightforward idea. So what here happens is that you have been given two scenarios, and each scenario everything is mentioned to you. You just have to read that and understand that from the questions, and you can get your answers. So for example, something must be given there in the question, that first of all you will have to identify whether it is SI or CI. That is obviously given. So assuming that it is simple interest, which is SI, some statement will be mentioned like this, which is principal becomes n times in n years, something like that will be given. Now here what you need to understand is that the small n corresponds to how many number of times the principal is becoming, and capital N corresponds to in how many years it is becoming. So let's say it must be given that there is an amount which is kept at simple interest, and principal becomes 3 times in 8 years, something like that will be given. So from this all data you need to identify three things. One is simple interest or compound interest, second is in how many years it is going to become, and the second part is how many times it becomes basically. So all these data points you need to get it from that statement. Once you have these data points, what you need to remember is one simple formula for rate of interest, that is R in this particular scenario, and that rate of interest, the R, is given by a simple formula which is small n minus 1 into 100% upon capital N. So this is the formula that you need to remember when it comes to the rate of interest in this particular scenario, which is what the most important aspect. The second idea, the connected to that, where they might say principal doubles in capital N years. Now understand this, principal doubles yani how many times it is going to become. So it is going to become 2 times is what we can say simply, correct? So what you can simply do here is the value of small n times, if you understand, you just have to substitute 2 here in the same original formula, and when you do that, so this becomes what, 2 minus 1 into 100 upon capital N, correct? So 2 minus 1 is 1 into 100 is 100% only. So you get the same idea. So obviously don't remember that formula for principal doubling in SI, just simply remember the OG one, the original one, and you can get it for any other scenario also, basically going forward. So you'll have to remember the whole thesis. Now this is about simple interest. Same thing we can do it for compound interest also. Now here things slightly change. So for the compound interest, the first part, principal becomes n times in n years, sorry. Here there is unfortunately no formula, but you will have to understand one thing, that this thesis you will have to remember, that amount undergoes fixed multiplication in fixed time duration. This is what you will need to remember, which means whatever is the pattern that is given in the question, you will have to follow that. Pattern, and then so you can figure this out eventually. So this is the idea. But for principal doubling, there is a formula which you can remember clearly. So if compound interest and principal doubles, so this is the formula of R, that is 72% upon capital N, where capital N is in how many years it doubles. So this is what you need to remember basically as the concept. So hence I said very straightforward, very formula oriented 2 things, but remember them so that you can solve questions that are related to them in that sense basically. So these are the few things. Now coming to the last bit of the concept, which is the different time periods of compounding, which is half yearly and quarterly compounding, which we have tried to address with the help of a question, so that you can understand. So first part is, which says that the sum of 10,000 is kept at 40% per annum compound interest. Find the total interest and the total amount at the end of 1 year if compounding happens A, annually, B, half yearly, and C, quarterly. So two things first, if the duration is 1 year and if compounding happens annually, so what you need to remember first of all, that is that in 1 year the compounding is only going to happen only once, basically, because that is the interpretation of annual compounding. If it happens half yearly, that means in 1 year it is going to happen 2 times, because every 6 months the compounding will happen. And if it is going to happen quarterly, that means in every 3 months there will be a compounding. So in 1 year it is going to happen 4 times. So first, how many times the compounding happens. The second thing that you will have to remember is the value of R. So for example, if the compounding happens annually, then you will have to take R as it is. So whatever is given, so for example 40% is given, we'll take 40% only. But if it is going to be half yearly compounding, you will have to take the value of R as R by 2, which is half, basically, which is 20%. And for quarterly we are going to take R as R by 4, which is going to be 10%. So these are the data points first you need to remember. How many times compounding happens and what are the rate of interests. Now the only thing that is left for us is to calculate for every scenario that what is going to be the answers that they are looking for, that is total interest and total amount. So let's do the first one, the most easiest one. Compounding happens only once, so simply we have to do 40% of 10,000, which gives us 4,000 rupees as the interest, and then amount is principal plus interest, so that becomes 14,000 rupees. If half yearly, you have two options now. You can split this every 6 months and then do it manually and then get your answers by adding all the data points. But if you remember in the earlier part of the concept, you have learned something called as successive percentage. And here what is going to happen is we are going to do 20% rate of interest 2 times, because half yearly compounding, remembering the concept. So using all of that, what really can happen is that we can use successive, and if you remember the formula, which is going to be A plus B plus AB upon 100, and that is going to give you 44% as the answer. So what now we have to do is simply take 44% of 10,000 and we are through, basically. So 10,000 ka 44% is going to be 4,400 and amount becomes 14,400. Similarly, for quarterly compounding, 10% 4 times, obviously you can do it manually, numbers are easy, but use better approaches, that is successive percentages. So 210 ka successive if you do, you get 21% as the net change. Similarly, for the remaining 210%, you can get the same answer, that is 21%, and then you do 21 and 21 ka successive. So 21 plus 21 becomes 42, and 21 square is 441. 441 divided by 100 is 4.41. So 42 plus 4.41, that is going to be 46.41. And what we will have to do is calculate 10,000 ka 46.41%, which gives you 4641. So your final amount becomes 14461, basically. So that is what you need to remember. So these are the 3 scenarios of annual compounding, half yearly compounding and quarterly compounding, and these are the answers and these are the concepts that are related to that. Now few couple of pointers which will help us for solving the word problems. So the first part is, if there is nothing mentioned about the time duration or the time period of compounding, so obviously everybody has to assume it to be annual compounding. Why? Because if people start assuming different things, so everybody will have different answers. So to avoid that, the general thumb rule is you assume it annual if nothing is mentioned. The second part is, let's say only the word interest is given. So obviously then you'll have to use simple interest, and if bank or something like that is mentioned in the data, then you'll have to take compound interest, so that again you don't miss out on the concept properly, and you can solve the questions that are associated with them. So let's try and solve the questions basis this SICI thing. So the first question says a sum of money compounded annually amounts to 12,800 in 8 years and 9,800 in 6 years. Find the rate of interest. So if you remember the property of compound interest, that the ratio between two consecutive amount is always same basically. So here what they have given is that they have given 8-year amount and they have given 7-year amount. Sorry, 6th-year amount. They have not given 7th-year amount. So ratio, if you take for 8th year and 6th year, that is 12,800 and 9,800. Obviously, if you reduce that ratio, you're going to get 12,800 divided by 9,800, 0, 0. If you reduce 128 by I think it is 9,800. Okay, so 128 divided by 98, which is going to be simply 64 by 49. Yeah, and these are very special numbers, 8 ka square and 7 ka square basically. So the thing is that why this is happening, that because we have skipped 1 year, so the ratio is always going to be a perfect square. So you can split it into two equal numbers of 8 by 7 and 8 by 7. Now what you need to understand is, in a similar type, they might skip, let's say, 2 years. So if they skip 2 years, whatever ratio will always be a perfect cube, because then you can split it in 3 equal numbers, and that is what the idea that you need to remember going forward. So the point is, if I am supposed to go from 6th year to 7th year, I should simply multiply by 8 by 7 to get the 7th year ka number, and from 7 to 8 again I should simply multiply by 8 by 7, and hence for 2 consecutive years the number is 128 by 98, or rather 64 by 49. Now if you also remember, for percentage increase we have given you a formula which is 1 plus base fraction, and that number, I mean 1 plus what, suppose x, and that number is now 8 by 7 for example. So 1 plus what is 8 by 7? Obviously 1 by 7, and 1 by 7 if you understand in percentages is going to be 14.24 percentage. 14.24 percentage, that is going to be your number. So I think rate of interest is 14.28%. So this is how you need to remember. For skipping one value, the ratio will always be perfect square. So you can split it into two equal numbers and then just simply solve for this entire idea, which is going to give you the answer as 14.28%. So this calculation was important. I feel that 8 by 7 तो probably समझ गया होगा सबको. One more time, for percentage increase, the formula is 1 plus base fraction, and that is 8 by 7. So how much is x, which is 1 by 7, because 1 plus 1 by 7 is 8 by 7, and 1 by 7 in percentages turns out to be 14.28 percentage, which is your answer. So answer option 2 for the first one. Second one, classic question. They have said that the difference between SI and CI for the first 2 years is given as 42 probably, and also what they have done is they have given the total simple interest earned for this period as 1680, and we have to find out the principal basically. Now here, since difference is given, automatically in your head we should use difference ka formula that we have done in the concept, the extra concepts that we did earlier. So there are two formulae. One is R% of I1 and the other one is R% of P. So which one we are supposed to use? So obviously we cannot use the second one because neither we have R, neither we have P. P is, so we are supposed to find it out only, so it is also an unknown. So we have two unknowns in the second formula, so can't use that. Has to be the first one, which is R percent of I1. But then you need to understand what is I1 here. So if you remember the fundamentals, I1 is we described I1 as first year ka interest. And if you understand the concept, they have given the simple interest and the language, look at the language, total SI earned for 2 years basically. So 2 साल का simple interest is 1680 and simple interest is constant every year. So if for 2 years 1680, obviously 1 year should be half of that, which is going to be 840. And now we can use the formula. So difference is 42, R percent, and interest, now we have figured it out, 1680 ka half, which is 840. So this 840 goes here, this becomes 42 upon 840 is equal to R percent. If we solve this further, you get R percent as 42 2za 84. So this becomes 1 by 20, and 1 by 20 as a fraction, you should remember the percentage, it is supposed to be 5%. So we have gotten R after solving this, that R is 5%. But we are supposed to find out the principal. Now there are multiple ways in which you can function. You can either use now difference ka formula, the second formula now you can use R percent of P, and here you have R, you have difference, you can get P. Or I will simply use simple interest ka formula, which is much easier to understand, which is PNR upon 100 simply. If I use simple interest as 1680, then I should use the duration as 2 years. If I use at 840, then I should use the duration as 1 year. So that is also something that you need to remember. So rate interest, we have just now gotten R as 5. Let's solve this. So this is 5 to the 10, and then this 10 goes off. Obviously this 10 goes there. So principal is 16,800, which is your answer, which is your first answer option basically. So very simple. All you have to do is understand the formula and then solve it accordingly and make it simpler. So very straightforward question as the second one. Let's talk about the third question. So the third question is the difference between SI and CI for the first 3 years at 10% per annum is 93. Find the total simple interest earned. And this is where a lot of people get it wrong because they still use the formula for difference. But if you remember very carefully, the formula for difference that we have done is only and only applicable for the first 2 years basically. So for the first 3 years there is no formula. So first what we'll need to do is we'll need to derive something. And if you remember, the rate of interest is 10%. So what we can say is, starting as the solution, for example, that let's suppose if the 10% is the rate of interest, then for 3 years the total SI would have been 30% of principal, because 10% every year. So for 3 years it becomes 30%. Clearly you can understand that. But what about total compound interest? So clearly it cannot be 30. So what we should do is we should do successive percentage. So दो 10 का successive अभी तो याद भी रहना चाहिए ये सारे numbers, which is 21 and 21 और 10 का अगर हम successive करें, so this is what you get. So 31 and 2.1, which is going to be 33.1. So total compound interest becomes 33.1% of principal basically. Now if you further want to solve this, I mean, now you can take the difference. So difference is going to be, if you really take the difference, it is 3.1% of principal to be precise basically. 3.1% of principal to be precise. Now we can substitute. So difference was 93. 3.1% of principal 3.1% is 3.1 upon 100 into P. So I need P. So this whole thing goes here and reverses. So this becomes this. Now I remember, if numbers are good, see how advantages, how many advantages you will have. So 31 3 is 93, but this is 3.1. So it must be not 3, it must be 30. And 30 into 100 is going to be 3000 basically. So after calculating the principal 3000, they were asking but total compound interest. Now what I can do is I can simply go here and substitute and I will get the answer after solving. But I will not recommend that because the numbers are not good. 33.1% of 3000. Instead, what you can do is you can think of simple interest. Why simple interest? Because the number is friendly and you can do it orally also if you are good. So for example, 30% we have to find out. I know we are not supposed to find out SI, we are supposed to find out CI, but I'll come to that in a bit so that you understand this. So 30% of principal, and principal is 3000. So 30% of 3000, obviously 3 3s are 9, so 900 is your SI. But they were asking CI, compound interest. And now comes the best part. If you remember the data, the difference between SI and CI is given, which is 93, and you have simple interest. So how you are going to get CI? So all you do is add the difference to that. So that gives you the answer as 993, which is answer option 3 basically. So this is how you would have done this faster and much easier, but core philosophy remains the same. The formulae for difference that we have done are only and only valid for the first 2 years. That is the biggest disclaimer. So here it is first 3 years, so no formula is applicable. So more than 2 years, no formula. You'll have to manually first of all figure out the rate of interest and then take the difference and then move on for the further calculation. So very, very important this idea. Do remember so that you don't make the same mistake. So that is about question number 3. Now moving on to the next one, that is question number 4. What do we have here in question number 4, which says the difference between SI and CI for the 2 years is 800 and 20% per annum rate of interest. Find the principal. Lot of people use the formula difference is equal to R% of P, because R is given, difference is given, P we can find out. But that's a big mistake that you will be making, because they have not specified that which 2 years it is supposed to be. And if you remember, just now a minute ago, 30 seconds ago, I said this point, that the formulae for difference are only and only valid for first 2 years and no other years. So here the confusion would have been which 2 years, whether it is middle 2 years, last 2 years, we don't know that. So clearly we cannot solve. So ideally you should not waste your time, and these are your 5-10 second shortcuts that you need to remember. So mind you, one more time, the formulae for difference are only and only valid for the first 2 years, and beyond first 2 years we did for question number 3. That is how you need to function. And if you not mentioned first 2 years, we cannot find out the answer. So go back to question number 2 and 3 and read it one more time. Question number 2, they have precisely said first 2 years the difference. The third question said first 3 years the difference, and so on and so forth. Very, very particular. One word here and there, everything changes drastically. So be very, very careful. So answer is option 5 straight away. Cannot be determined. Don't even waste your time. Now talking about the 5th question, which says a principal or a sum kept at simple interest becomes 4 times in 7 years. Find the time taken for amount to become 28 times. Now clearly this first half, SI principal becomes n times in n years, multiplicity of principal wala concept. We know the formula. R becomes small n minus 1 into 100% upon capital N, where small n is the number of times and capital N is the number of years. Basically, all we need to do is substitute in this formula. So 4 minus 1 into 100 upon 7. So this becomes what? 300 by 7%. If you want, you can simplify. 1 by 7 is 14.28, so 3 by 7 is 42.8485%. Now, what they were asking, so same calculation I think is going to come up. So I'll just erase this bit. So now they are asking that time taken for amount to become 28 times. So now we are supposed to find out capital N, and small n is given, that amount is going to become 28 times. So again we can use the same formula. R is small n minus 1 upon capital N into 100% basically. R we can simply use from here. I will not use 42.85. I will use 300 by 7 because it makes things easier for the calculation part. So same formula, if I substitute 300 by 7, small n 28 times, so 28 minus 1 into 100 upon capital N. So n goes here, this all comes here, so this is 2700, the 7 by 300. 3 9s are 27, 9 7s are 63. So 63 years it should take for amount to become 28 times at this particular pace, for example. So this is your fifth question. So straightforward idea. If you remember, I keep on saying this, simple formula oriented questions. You need to just remember that idea very clearly and apply it, and you are good to go. Now understand one thing. In such type of question, only they can change numbers. Nothing else can be changed. Everything will remain same. The numbers will change, the calculation will change. The thought process, the philosophy, the solving part will all remain the same. So focus on such things which are easy to solve. Let's do the next one, which talks about compound interest now. Very interesting. Which says a sum kept at compound interest becomes 4 times in 7 years, and find the time taken for amount to become 64 times. Now this is exactly what we were talking in the concept also, that in such case of compound interest, principal becomes n times in n years. Unfortunately, there is no formula. The formula is only there for principal doubling in compound interest, which is 72% upon capital N. So what we need to do is, we need to follow the pattern that is mentioned in the question itself. And the pattern is amount becomes 4 times in every 7 years, for example. So let's begin. So I'm assuming, let's say I have 10 rupees as a principal. If I invest this in this particular scheme where it gives me 4 times in every 7 years basically. So what will happen is, in the first 7 years, it will become 4 times of what I am investing. So if I invest 10 rupees, it becomes 40 rupees. Now, in the next 7 years, it again should become 4 times. So 4 times of this is not 80. A lot of people make that mistake. Times is word, as a word, it means multiplication. You're supposed to multiply. So it becomes obviously 4 4s are 16, 160 rupees. In another 7 years, so that is the total time is 7 plus 7, that is 14 years have passed basically. And in another 7 years, if I keep continuing this, another 7 years, it should again becomes 4 times, right? So 16 4s are 64, so 640 rupees basically it should become. In another 7 years, that is 14 plus 7, that is 21 years. Now if you compare the original number was 10 rupees. and they were saying amount to become 64 times, and I've gotten now it to be 640 rupees. If I compare that 10 and 640, can I say it has become 64 times? Yes, absolutely. And the question was in how many years it has happened. So obviously 21 years it took to happen. So point is, if the pattern would have been something different in the question, this whole thing will change, and hence you have to follow the pattern that is given in the question. So you can simply assume something and keep doing it. So for every 7 years time period, the amount is becoming 4 times every time. So 4 times of the previous, 4 times of the previous, and you keep adding 7 years. After 3 iterations, you understand to become 64 times, it is going to take 7 years के 3 groups, यानी 3 tranches you can say. So that is going to give you 21 years as the final answer basically for question number 6. Now let's do the 7th one, the last one for simple interest and compound interest, which says a sum of 10,000 is kept at 10% per annum rate for 2.5 years compounded. What is the total amount accrued if it is annual compounding? So very straightforward idea. The first thing you will have to do is, because it is annual compounding, but the duration is only 2.5 years, so you can do like 10 के 2 iterations, and for the remaining 6 months the rate of interest will also go down, that is it will become half. So instead of 10 it will become 5% basically. So let's do compound interest. See, because if it would have been SI, then it is easy, we just simply have to add these. So it would have been 25% basis 10% per annum for 2.5 years, because 10 for first 2 years and 5% for the remaining 6 months. But because it is compounding and compound interest, we will have to first find out the rate of interest. So by now you should remember the numbers also straight away, but I will still do it. So this is 20 plus 1, that is going to be 21, then 21 and 5 if we do the successive. So 21 plus 5 is 26, and 21 5s are 105. 105 divided by 100 is 1.05, which is going to be 27.05% rate of interest flat. And this is what you can straight away calculate for 1000. So if I want to now calculate the interest is going to be 27.05% of 1000 simply, and that gives me the answer, I think, as 270.5, which is your interest component. But they were asking the amount, total amount. So amount, you know, amount is principal plus interest. Principal is 1000, interest is 1270, amount becomes 1270.5, which is answer option 5 for question number 7 of SICI. So this is what the whole idea of SICI. So obviously try this out, try yourself and go through all of this in detail. Same thought processes again. If you have any questions, do let us know. We'll be happy to assist you in any manner. So thank you so much, guys. Have a great day.